Okay, real talk. You've done it. I've done it. Every single person watching this has done it at least once. You're holding something, maybe a cup, maybe your phone, maybe a plate you were so sure you had a good grip on, and then your fingers slip. Just for a moment. Just a tiny bit. And before your brain even has time to send the catch it signal, it's already on the floor. And in that split second, that horrible half second between letting go and the crash, something interesting happens. You already know what's coming. You don't think about it. You don't calculate anything. Some deep, ancient part of your brain just knows. It's going to fall. It's always going to fall. It has never, not once in your entire life, gone up. But here's the question nobody really stops to ask. Why? Why down? Why not sideways? Why not up? Why does literally everything? Your keys, your food, your tears, your dreams when you drop them. Why does it all go to the same place? The floor. Always the floor. That question right there, that's one of the oldest questions humans have ever asked. And the answer is one of the most beautiful stories in all of science. So let's talk about it. Before we get into our 5 big insights, I want to set something up, because there's a version of this question that sounds simple, and then there's the version that keeps physicists up at night. The simple version, things fall because of gravity. You learned that. I learned that. We all learned that. Gravity pulls things down. Done. But here's where it gets interesting. What is gravity, actually? Where does it come from? Why does it pull everything toward Earth and not push things away? Why does it work on your keys and on the moon at the same time? Why does it never take a day off? See, gravity is a word. But behind that word is one of the deepest, most surprising, most human stories in science. A story about a young man sitting under a tree. About planets dancing in perfect circles. About space itself bending like a rubber sheet. About something so fundamental to the universe that it connects you, right now, sitting where you are, to every star, every galaxy, and every piece of matter that has ever existed. So no, we're not going to just say gravity and move on. We're going to actually understand it. 5 insights starting from the ground up. Let's go. Here's something that's going to sound strange at first. Ready? Right now, you are pulling the Earth toward you. Not just the Earth pulling you down, you are pulling it up. Simultaneously. At the same time. Right now. I know, that sounds ridiculous. But it's true. This is what Isaac Newton figured out in the 1600s, and it changed everything. He called it universal gravitation, and the universal part is the key word. Every single object in the universe that has mass, meaning every object that exists and takes up space, pulls on every other object. Always, without exception. Your phone is pulling your hand toward it right now. Your coffee mug is pulling your laptop toward it. You are gravitationally pulling on the person sitting across from you, and they are pulling back. The moon is pulling on every drop of ocean water on Earth, and that's literally what causes tides. Now here's the thing, you don't feel yourself pulling the Earth toward you, because the pull between 2 objects depends on how much mass they have. Earth is enormous. You are considerably smaller. So Earth's pull on you is powerful enough to keep you firmly on the ground, while your pull on the Earth moves it by a distance so tiny it's effectively 0. But here's the human truth in this. You are not passive. You are not just being acted upon by the universe. You are participating in it. Gravity isn't something that happens to you. It's something that exists between you and everything else. You are connected by an invisible pulling force to the Earth, to the moon, to distant stars. You have always been part of this. The universe noticed you the moment you had mass. So now we know everything pulls on everything. But why does Earth win? Why does everything fall toward Earth specifically and not, say, toward the nearest lamppost or toward the moon? The answer is beautifully simple. Mass matters and distance matters. Newton worked out the exact relationship, and it goes like this. The more mass an object has, the stronger its gravitational pull. And the closer you are to an object, the stronger that pull feels. Double the mass, double the pull. Get twice as close, the pull gets 4 times stronger. Earth has an enormous amount of mass, about 6,000 trillion kilograms. That's a 6 followed by 24 zeros. So its gravitational pull is enormous. The lamppost next to you has some mass? Sure. but it's so tiny compared to Earth that its gravitational pull on you is essentially nothing. The moon has significant mass too, and it does pull on you, but you're much, much closer to Earth's center, so Earth wins by a landslide. Here's the relatable moment in this. Think about influence in your own life. The people closest to you, the ones with the most presence in your world, have the strongest pull on you. A stranger across the world might be wonderful, but they don't shape your daily life the way the people in your immediate environment do. Gravity works exactly the same way. Closeness and size create influence. The universe understood this long before humans did. This next one genuinely changed how I see the universe, so stay with me. We think of falling as a thing that happens when you drop something. But what if I told you that falling is happening all the time, even when things appear to be floating or orbiting? What if the moon is actually falling toward Earth right now? It just keeps missing. Here's how it works. When you drop a ball, it falls straight down. But if you could throw that ball fast enough, sideways, horizontally, something interesting happens. The ball still falls downward due to gravity. But because it's moving forward so fast, by the time it has fallen a little bit, the Earth's surface has curved away beneath it by the same amount. So it never actually lands. It just keeps falling and falling and curving around the Earth. That's an orbit. The moon is doing exactly this. It's in a constant state of falling toward Earth, but it's moving sideways so fast, about 1 kilometer per second, that it continuously misses the surface. It's been doing this for about 4.5 billion years. It's the most elegant near miss in the history of the universe. This concept is called gravitational acceleration, the idea that gravity causes everything to speed up as it falls at the same rate regardless of mass. And the orbit insight comes from understanding that moving sideways fast enough means you fall around something instead of into it. Here's the human parallel. Have you ever been in a situation where you were constantly running just fast enough to stay afloat? Working hard enough to keep things together, but never quite escaping the pull of something? That's orbital mechanics in human form. Sometimes staying in motion is the only thing keeping you from crashing. The moon figured this out. And honestly, sometimes we do too. Okay, everything we've talked about so far is Newton's version of gravity. And Newton was brilliant. His description of gravity worked so well that we used it to land people on the moon. But in the early 1900s, a man named Albert Einstein came along and said something that made physicists drop everything they were doing. He said, "Gravity isn't a force." Wait, what? Then what is it? Einstein's answer, which he called the General Theory of Relativity, is this: massive objects don't pull on other objects through some invisible force. Instead, massive objects bend the fabric of space and time around them, and other objects don't get pulled toward them. They simply follow the natural curves in that bent space. Think of it this way. Imagine space is like a large flat trampoline. You place a heavy bowling ball in the center. The trampoline sags and curves around the ball. Now you roll a small marble across the trampoline. The marble doesn't travel in a straight line. It curves toward the bowling ball, following the shape of the sag. From the marble's perspective, it's just going straight. But the surface it's traveling on is curved. That's gravity. Earth is a massive object. It bends the space around it. When you drop your keys, they don't get pulled down by some invisible hand. They follow the curve in space that Earth has created. They're just going the most natural direction available to them. Here's what makes this deeply human. How many times has your environment shaped your direction without you even realizing it? The place you grew up, the people around you, the circumstances you were born into, they curved the space of your life. You moved in the direction the world bent toward. That's not weakness. That's physics. Even light does it. Gravity bends the path of light itself. Einstein proved it. It was confirmed in 1919. Even the thing that moves fastest in the universe follows the curves around it. This last point is the one I want you to sit with for a moment. Without gravity, none of this exists. Not the Earth, not the sun, not the stars, not you, not the air you're breathing right now, or the chair you're sitting in, or the atoms that make up every cell of your body. Without gravity, the universe would be a thin, cold, invisible mist of particles spreading out forever into darkness. Never touching, never clumping, never forming anything. Gravity is what took that mist and said, come together. This is called gravitational collapse and structure formation, the process by which gravity causes particles of gas and dust to gradually pull toward each other over millions of years. The clumps get denser. Denser means more mass. More mass means stronger pull. Stronger pull attracts more material. Eventually, the clump is so dense and hot that it ignites. A star is born. Gravity then shapes the material left around the star into planets. On at least one of those planets, ours conditions are just right. And over billions of years, gravity keeps holding everything together while that cup didn't just fall because of physics. It fell because the universe spent 14 billion years building the conditions that put gravity and Earth and matter and you all in the same place at the same time. Here's the human truth in this. You are not random. You are not an accident floating through an indifferent universe. You are the result of the most patient, powerful, consistent force in existence. A force that has been building toward you since the beginning of time. Gravity didn't just shape the planets. It shaped the conditions that made your existence possible. The same force that pulls your keys to the floor also pulled the atoms of your body together, held the Earth in orbit around the sun, and kept the sun burning long enough for life to happen. You are, in a very real and scientific sense, a product of gravity. And that, I think, is worth sitting with for a minute. So, let's land this appropriately enough. We started with a falling cup. And what we found is that behind that single, ordinary, everyday moment is one of the most profound stories in science. Everything falls because every object with mass pulls on every other object. Earth wins because it's enormous and it's close. Falling is actually a continuous curve. The moon is proof that falling doesn't have to mean crashing. Gravity isn't even a force pulling you. It's the shape of space itself, bent by mass, guiding everything along its natural curves. And without all of this, nothing, not planets, not stars, not life, not you, would exist at all. The next time something slips from your hand and hits the floor, I hope you feel something different for just a moment. Not frustration or, okay, maybe still a little frustration if it was your phone. But underneath that frustration, maybe a tiny flash of wonder. Because what just happened wasn't just a clumsy moment. It was the universe doing what it has done, perfectly and without fail, for 14 billion years. It was gravity, the oldest, most faithful force in existence, doing its job. And you got to witness it. From the inside. That's not nothing. That's everything. If this video made you look at the floor or the sky a little differently today, then I'm genuinely glad you watched it. If you're new here, welcome. This is the channel where we take the questions you've always had but never quite asked. The ones that live in the back of your brain at quiet moments, and we sit with them together until they make sense. No jargon, no judgment, no prior physics knowledge required. Just curiosity and a willingness to look at ordinary things in extraordinary ways. Hit subscribe so you don't miss what's coming next. Every week we take something from everyday life, something you've seen 100 times, and we find the universe hiding inside it. And if today's video sparked a question, any question, drop it in the comments. Why does time slow down? What is light, actually? What would happen if gravity suddenly stopped? Your questions are the best ones, and they become our next videos. I'll see you in the next one. Keep looking down. Keep looking up. The universe is in both directions. Take care.